Alright, today we're going to talk about reference angles, but this time in radians. So all of these things we've done before in degrees, but we're coming back to them in radians now, so they'll look different. And remember when we did these problems that we found all the positive angles between 0 and 360 that had the following reference angle. So say for example this 40-degree one here. Some of you got so good at this you never used the picture anymore. You knew that this was 0 degrees, and so if you were 40 degrees away from 0, you were at 40 degrees. That was one of your answers. You knew that if you started here and you were 40 degrees away from this x-axis, this was 180. You did 180 minus 40 and learned that you were at 140 degrees. That angle is between 0 and 360 and has a 40-degree reference angle. We knew that if we started here and we were 40 degrees away from the x-axis in quadrant 3, we would be bigger than 180, so we added to learn that this angle was at 220 degrees. And we knew that we could be 40 degrees away from the x-axis in quadrant 4 when we would think of the x-axis as 360 degrees. We knew we were smaller than that, so we would subtract 40 and learn that we were at 320. We have to do that sort of problem, but have our work in radians. So we need to know that this is still considered 0. We know that there are 2 pi radians in a circle, so instead of 360 that would be 2 pi. When we divided that by 2, we learned that 180 was equal to pi, so this would be pi radians. Now we have to fill these two in. This one is halfway between 0 and pi, so it would be pi divided by 2. And this one's a little harder to do that with. This one's between pi and 2 pi, so it's between 1 pi and 2 pi is 1.5 pi. But what's 1.5 as a fraction? The smallest fraction that makes 1.5 is 3 divided by 2, so it's 3 pi over 2. The other way you could get that would be by taking 270 degrees and multiplying by pi over 180 to change it to radians. And you'd figure out that that equals 3 pi over 2 as well. That would be another way to get that answer that we just got there. Alright, so the first type of problem we're going to do is what we did here, but getting the radian measures because they're giving us a radian instead of a degrees. Okay? So, since we're working with fractions, it's going to be all about common denominator finding. 0 does not need a denominator, that's for sure. But if pi is over 1, and we're going to be wanting to add something with a 6 on the bottom and subtract something with a 6 on the bottom, then we're going to want to change this to have a 6 on the bottom. So let's multiply it by 6. Top and bottom, and let's call it 6 pi over 6 instead of pi. Okay, let's do the same thing with 2 pi over here. 2 pi has a 1 on the bottom, but since we're going to want to subtract something with a 6 on the bottom from it, let's make the equivalent fraction by multiplying top and bottom by 6 here, so we'd have 12 pi over 6 instead. Okay. We don't need the 90 degree and the 270 degree. We don't need the pi over 2 and the 3 pi over 2 because we're working with reference angles. So we're just going to be working with 180 and 360 and 0. Okay, so if we are pi over 6 degrees away from 0, we know that we are 0 plus pi over 6. Pi over 6 would be one of our answers. Or we might be pi over 6 away from the x-axis in quadrant 2. which means we are pi over 6 away from 6 pi over 6. 6 pi over 6, take away pi over 6. Remember, there's a little invisible 1 right there. 6 minus 1 would be 5 pi over 6. Remember, when you're adding or subtracting fractions with a common denominator, the denominator doesn't change, just the numerator. All right, if you're pi over 6 away from the x-axis in quadrant 3, again, you're pi over 6 away from 6 pi over 6. But this time it's bigger, so you should add. So if there's an invisible 1 right there, you're adding 6 plus 1 makes 7. And keeping the denominator the same. Or if you're pi over 6 away from the x-axis in quadrant 4, then you know that you're pi over 6 away from 12 pi over 6. It's before you get there, so it should be smaller, so we should subtract. Remember, there's an invisible 1 there, so 12 minus 1 makes 11. After you've done a few of these, you'll get comfortable and not need to write those down, because you're going to remember that you're just subtracting the numerators, and so you'll mentally subtract them and you'll come up with that 11 pi over 6. Okay? Okay, give that a try. See if you need follow-up questions asked in class on that type of problem. And then we'll move on, before the video gets too long here, to the other type of problem that will work with radian measures of reference angles. Draw the angle in standard position and then label the reference angle. Find the measure of the reference angle. Okay, this is based on what we did on the previous question. We know that this is 0, and this is pi, and this is 2 pi, 1 pi, 2 pi. We should look at the denominator we're going to be comparing with, which is a 6, and say, oh, okay, I'm going to convert this pi over 1 to have a 6 on the bottom by multiplying the fraction by 6, top and bottom. I'm multiplying by something that's equal to 1, so I'm changing the appearance of the fraction, not the actual fraction. Okay. So then I can look at 7 pi over 6 here and say, oh, okay, I'm bigger than 6 pi over 6, so I know I'm not in quadrant 2. I'm a little bit bigger than 6 pi over 6, I'm 7 pi over 6, so I'll be in quadrant 3. Okay. Label the reference angle. The reference angle is the distance between where you stopped and your x-axis, so here. And then find the measure of the reference angle. This time we know that we're looking for the difference between these two measurements, so we're going to subtract them. Some of you can mentally do this already. 7 pi over 6, take away 6 pi over 6, leaves us 1 pi over 6, or pi over 6. Okay. Let's try something with a different denominator. A 3 on the denominator. So that's 0 degrees. This is pi, but if I convert it to have a 3 on the bottom, that'd be 3 pi over 3. So 7 pi over 3 seems way bigger. Okay, what would be 2 pi? Gotta write a little down here, don't I? 2 pi over 1, if I multiply by 3, would be, to make an equivalent fraction, would be 6 pi over 3. Oh, we're even bigger than that. So this is an angle that's gone all the way around the circle, and it's going to go beyond 6 pi over 3. So it's going to be back into quadrant 1 after making a full lap. The reference angle is going to be between where I stopped and the x-axis, so right here. And since I went a whole circle, I'm not going to treat this like 0, I'm going to treat this like 6 pi over 3. So if I'm at 7 pi over 3, when I stop, and I take away 6 pi over 3, I know that my reference angle, my difference, is pi over 3 in size. And so that's the size of my reference angle. Okay, if that's enough for you, you can stop watching the video, but I'm going to keep going a little bit because this is a tricky one. Okay, what if there's a 4 on the bottom? This would be 0 radians. If you had pi over 1 and you multiply by 4, this would be 4 pi over 4, right? And if you had 2 pi over 1 and you multiplied by 4, that would turn into 8 pi over 4, would it not? Alrighty, so 3 pi over 4 is smaller than 4 pi over 4, so I actually didn't need to find that, did I? How do I know for sure that it's in quadrant 2, not quadrant 1, by the way? If I had pi over 2, and I wanted to convert that to a 4 on the bottom, I'd only have to multiply by 2, wouldn't I? So this would be 2 pi over 4. So it's bigger than 2 pi over 4, it's smaller than 4 pi over 4, so it's got to be here in quadrant 2. The reference angles between where I stop and the x-axis. And to find the size of that, I subtract. So 4 pi over 4, take away 3 pi over 4, leaves 1 pi over 4, or just pi over 4. Okay. Last one for good measure. So 0. 11 pi over 11. I turned my 11 into a pi, didn't I? Or 2 pi, that'd be 22 pi over 11. 6 pi over 11 is smaller. How do I know for sure it's here, not here? This one's a little tougher because of the pi over 2 and the 11 being an odd number. So I think I'm going to just have you reason through it. If this is 11 over 11 and this is half of that, what's half of 11? 5.5, right? So I would have to multiply by 5.5 to get an 11 on the bottom. And so if I multiply to 5.5, that would be 5.5 times pi. Not exactly your standard radian form. We wouldn't want a decimal in a radian like that. But it helps us position. 6 is a little bit bigger than 5.5, so this angle is going to be a little bit bigger than the first quadrant. Okay, how big is the reference angle between where we stop and the x-axis? Well, we subtract to find out. So 11 pi over 5, take away 6 pi over 11, leaves us 5 pi over 11 for the size of that reference angle. Okay, follow up as needed.